projection of straight lines, right? Projection of straight line in various orientation respect to vertical and horizontal planes. We end up with the projection of a straight line inclined to both cases, inclined to both HP and VP, right? So we have projection of line if theta plus phi is equal to 90 degrees. Right. So projection of line if theta plus phi. So in this case, it's a line inclined to both vertical plane and horizontal plane. Right. So what is the inclination to horizontal plane? It is theta. So what is the inclination to vertical plane? It is phi. Okay, if I sum it up, theta plus phi, if it is 90 degree, what will be the orientation of the straight line? I will have a straight line. Okay. A straight line. Suppose I plane like this. Okay, this is the orientation it will be. Right. So this angle and this angle to VP and this angle to HP. So VP and HP both it will be 90 degree. If I add it, it will be perpendicular. It will be 90 degree. So in that case, what will be your front and what will be your top view? A vertical line. Okay, front view also a vertical line, top view also a vertical line. Both will be on a same projector line. Okay, there is no inclination. If in this case theta plus phi equals 90 degree, okay, then your front view and top view will be a straight line. Will fall on a single. This is the case. I have a line. Say, this is the line. I have A over B. So the projection will fall here. This will be my front view and this will be my top view. Right, you can see here, this inclination, both this inclination, this is theta, this is phi. If we add it, theta plus phi, it will be 90 degrees. So this is my projection, A dash, in the front view, this is B dash, this will be my A, this will be my B. Right, projection, both the projections will fall on a single projector line. So definitely, you look at the problem, list out the data, you add the theta plus phi. For any case, you add the theta plus phi. If it is 90 degree, you can confirm that the both front view and top view will fall on a single projector line, not like this. Okay. So the previous last class we have seen it is theta is 30 degree, phi is 40 degree. So the summed up value will be 70 degree. It is not 90 degree. So if the angle theta plus phi is 90 degree, then your projection will have a single projector line. Front view and top view will see here the projection definitely will be X, Y. It will fall on a single projector line. So the final projection X and Y will fall on a. See here. We'll continue. See here. As for this case, if the angle summed up angle is 90 degree, both the front view and top view will fall on a single projector line. This is going to be my front view and this is going to be my top view. Right. So remember this case, A dash, this will be B dash, this will be A, B. So like the previous problem, if I tilt it, it will cut the top locus. Okay. So what you will, due to your construction errors, you won't get it as a perfect, you won't get it on a same vertical line. You made it to be vertical. Okay, a small adjustment you have to do it. Okay, I should not tell. You see here, a small adjustment you have to do it and make it. It should be the final projection of the front view and top view should fall on a same projector line. Right? Is it clear? Line PQ. Wait for the line PQ of 75 mm. PQ 75 mm. Has its end P, on HP 1 HP on HP and 10 mm in front of VP, right? Full stop. The line is 35 degree inclined to HP and 55 degree inclined to VP. The line is 35 degree inclined to HP and 55 degree inclined to VP. Inclined to VP. So draw the front and top view of the line. Draw the straightaway data like the previous one. Okay. So I have a true length, I have a one end location, then I have theta, I have phi. Just to add this theta plus phi is 90 degree. In this case, 35 plus 55 will be 90 degrees. Then you should be careful while rotating the final front view and final top view. It should fall on a single projector line. You don't have two projectors like the previous one, right? So carefully you have to draw it. But the similar same procedure you have to follow it, you can do it, right? Do it later. Then we will go to the next one. True inclinations of the line. Right, see here, finding the true length is nothing but here, true inclination to HP and true inclination to VP, nothing but theta, phi. Right. Suppose in a problem, you see here, finding the true length and true inclinations of a line, okay, of a straight line. So you have two methods. Just see, I have two methods. One is rotating line method. How we are drawing the final projection is nothing but a rotating line method. Rotating line. Another one is trapezoidal method, right? So I have two methods. How to find the line? Okay, take a problem. A line AB, a line AB has its end A. A line AB has its end A. See here. End A. Above HP, 25 and 25 in front of VP. And end B, 45 above HP, 40 full stop. Draw the distance between the end projectors of the line. The distance between the end projector of the line is 60 mm. The distance between the end projectors of the line is 60 mm. Full stop. Draw the projections. Find the true length and true inclinations. Find the true length and true inclinations to HP and VP. So I have to find true length, I have to find theta, I have to find phi. Right. So using this, I have, as I told in the earlier lecture, you will be given 5 data, you are asked to draw the projection and you are asked to find out some missed out data. So see here, I have to find out true length, I have to find out the true inclination. The previous problem we can see, the true length is given, true inclinations theta phi is given. Like this problem, true inclinations theta phi is given. Now here some other 5 data is given. So end A's location position is given, end B's position is given, and and the end projector distance is given, and you are asked to draw the projection and to find out the true length and true inclination. Right. So how to do it? Like in rotating line method and in trapezoidal method. See here, it is given, clearly given. You can see. What is the above distance is 20 mm. This is my A dash. This is my B dash. This is my A. This is my B. So this is going to be my front view, and this is going to be my top view. Right. Straight away, you know the previous problem in the last lecture. Right. Straight away plot the data is given. So one end is projection is given, that is A dash and A, I can mark it. Right. Another end, that is end B is above distance and in front of distance. What is end B is above distance? 45. 45. So what is that actually? Above distance of end B. So here, we should draw the projection is given, that is 20 mm above HP, right? 20 mm and 25 mm in front of the peak. So this is A dash, this is A. See here, listen, this is A dash and A. So I have used the first two data, the second two data, that is NB is above distance and NB is in front of distance. Okay, in the previous problem we can say what is the locus of B dash? It is nothing but the on locus of B dash only I am going to have my B dash. It is nothing but B dash is nothing but the above distance from the reference line. Okay, it is B dash is nothing but the above distance from the reference line. So this is my above distance to the reference line, above distance of B. Right. The bottom one, bottom locus is nothing but in front of distance of B. So it's same. Here if I draw a line horizontal, that is nothing but the locus of A dash. Here if I draw it, that is nothing but locus of A. So where is going to have the other end B's projection? The horizontal line drawn parallel to that, it is nothing but a locus of end B. Locus of end B, right? So bottom one is the locus of n B, top one is locus of n projection B dash, right? Is it clear? So what I can do the other two data, using that I can straight away draw the locus. Okay, in my problem, straight away I can draw the locus using the above distance of NB, that is 45 mm. 45 mm. So at 45 mm, I can draw the locus of B dash. This is my locus of B dash, right? Locus of B dash. See here. So similarly, it is 45 mm above. It is given is 45 mm above. So similarly, I can draw B. Okay, I can measure 40 mm. Measure 40 mm. I can draw the locus. This is my locus of B. This is 40 mm. Right. So what is the another data I can use it? The previous last class third problem, you use it as a template, right? What is another data I have? N projector distance. I can draw two projectors. Okay, so one projector I have A dash A. Another N's projector is what? It is 60 mm apart from the end A. So another projector I can measure 60 mm. I can draw another projector. See here, my another projector, this is my one end projector, this is my another end projector. So this is 60 mm, right? So using the previous problem as a template, you can see what are the data given. This data I have used 20, 25, 45, 40, 60. Okay, this is 20. This is 25. Right. Now your task is, so where I will have B dash and B. Locus of B dash, we got intersection of the another projector, end projector, right? Intersection of another end projector is here. Okay, with the locus, that is nothing but what my B dash. Okay, that is my B dash. This will be my B. Can you draw the final projection? So A dash I have, B dash I have, A I have, B I have. Just I can connect A dash, B dash. So this is my final project front view. Okay, this is going to be my final top. Right. So straight away from the given data, I have got my final front view and final top view. So what is first part is over. Then you have to find out the true length and true inclination theta and phi. How I can do it? So in the previous problem we had the true length theta phi. We have got the final projection. Now the final projection is straight away you have got it by just drawing using the given data. Now you have to find out the true length and true inclinations. In a ulta manner I can do it. Okay, the front view I can rotate it and make it to horizontal. Okay, the front view I can rotate it, I can make it to horizontal and I can project it to the bottom locus. What I will get? The true length I will get and the true inclination to BP I will get. Right? If I rotate the top view and make it horizontal, okay, that I will project it to the top locus. What I will get? Again I will get true length and true inclinations to HP. Okay, just what I am doing, just I am rotating top view, front view, right? Front view I am rotating. I am making it to parallel. It will be A dash and B2 dash. So I am rotating it in the negative direction. So A dash and B2 dash. Then what I have to do? I can project this to the bottom locus. How I have got this? I can project this to the bottom locus. So what is this? This is my B2 dash. This is B2. B2. This is B2 dash. This is B2. B2. So by joining A and B2. What is this? It is nothing but what? That is nothing but the true length. Okay. And this inclination to the reference line, to the horizontal, this is nothing. This will give me what? This will give me phi. Any inclination below the reference line, that will be phi. Right. You see here. So I have got my true length. This is my true length. I have got my phi. So same true length you have to get it by rotating this. So now I am rotating the top view, right, and making it to parallel. So I have A, B, 1, right. So by projecting this to the top locus, I will get my B1 dash. Okay, by joining this B1 and A1, this is again a true length. So what you have got the true length, what of these both are same. Okay, that you have to measure it and you have to dimension it. What will be this angle? What will be this angle? Theta. Okay, this is my theta. So this is how you can find it out. Okay, in the reverse manner you have to find out. Similarly, I can have any 5 data I can give, I can have to find out the off data. Is it simple or you are finding it difficult? Simple only, okay. You can solve any problem, okay. You can take it as a challenge, you can solve it any problem once you know this very well. Right. So just remember this and remember the notations, okay. How we have proceeded, right. First step, second step, okay, first step what all the notations we had, right, second step what are the notation, how we have arrived the final projection, okay. Once that is very clear, so any data you can plot it and the off data you can get it, okay. Right, so this is how I can find out true length and true inclination by rotating the front views and top view, finding the true length or true inclination. So it is called rotating line method, right. So I have another method that is the same problem, I can solve it by another method. Okay. So that is trapezoidal method. Right. Same problem we added. How to mark the traces HT, BT. How I can mark HT? How I can mark HT? HT is what it is, an intersection point of intersection with the horizontal plane of the line, okay, straight line, okay. So how I can proceed that, okay, this is the, suppose I have a, so this is projection what I have drawn in this 3D one. So the actual line will be this one. I can see this is my actual line. This is my actual line. So this is my A. This is my B. Right. So if I extend the original line to the horizontal line, wherever it meets, that is going to be my horizontal trace. So already we know that. So wherever it meets my horizontal trace, then have it like this. Okay. The same line, if I extend it to the, can it meet? Will it meet vertical plane? Anybody, will it meet the same line? Will it meet vertical plane? Why? Definitely it will meet. Vertical plane is not only you have in this quadrant, you are having it in the third and fourth quadrant. The vertical plane is going in the negative direction also, right? I have drawn only the first quadrant. Okay, the vertical plane is nothing but a plane that's going all the way through the bottom, right? Vertical plane is going all the way to the bottom. So the same line, if I still extend, okay, it will definitely goes and meets the vertical plane. Okay, but vertical plane also it will meet. Okay, where it meets the vertical plane, that is my vertical trace. Right. In a 3D manner, I have shown the horizontal trace and vertical trace. How I can mark it in my projection, from the projection. Okay, I have explained already. So, to have the note, just extend the horizontal front view, just extend the front view till it meets the reference line. To mark it as H and draw a vertical line. Okay, and extend the top view where it meets the vertical line you have drawn. That is going to be your horizontal trace. You see here, just I can extend the front view. Right. Where it meets the reference line, that is my H. I can draw a vertical line there. Then what I have to do, I have to extend my top view. Top view is nothing but this is my horizontal trace. Is it clear? Right. Then how I can mark the vertical? You can see here, I am extending the front view. Where it meets the that is my H. I am drawing the perpendicular. I am extending the top view where it meets the horizontal line I have drawn. That is my horizontal trace. So that is just for explanation. You have to draw it. You can, as a procedure, you can extend the front view to meet the reference line. You can draw a vertical line there. Okay. Then you can extend the top view where it meets the vertical line you have drawn. That location is my horizontal trace. Right. Same way, now I can draw the vertical trace. I have to extend the top view. Okay, the same manner already I have extended that. I can extend the top view till it meets the reference line. So where it meets the reference line is this. So that location is my V. I can draw a vertical line there. What I have to do? I have to extend, then I have to extend the front view. So where it meets the vertical line what you have already done. That is my vertical trace. Is it clear? You can see both HT and VT is coming below the reference line. Right? Is it clear? This is how you have to mark the horizontal and vertical trace. The same thing I can draw it using my another procedure that is called trapezoidal method. Right? I can find the true length and true inclination using trapezoidal method. So anyone you can use it. You see here the trapezoidal method. The same way, first of all, using the given data, you have to draw the projection first of all. Get the projection first of all. Data. Then I had B. The locus, right? Then I have the end projector distance 16. So I can mark my A, B dash, B. So this is my same problem, I have got the final, I have drawn the final projection. How I can find out using trapezoidal method. So what you have to do, listen, how I am drawing like this, I will explain, right? Just look at what you have to do, just the final projection what you have, you just draw perpendicular to that final projection. See here, this is a perpendicular I am drawing, this is a perpendicular I am drawing, right? So perpendicular to the final projections I have to draw it. Similarly, perpendicular, listen, perpendicular to the top view, what is this? This is perpendicular. Listen, say the procedure carefully. Okay, just I am drawing the perpendicular. So what you have to do? The in front of distance, right? Below the reference, what you have? It is nothing but the in front of distance of NA. This is the in front of distance of NB. This is the above distance of NA. This is the above distance of NB, right? So the in front of distance of NA, this one, what is that distance? That is, you know, it is 25. That you have to mark it from A dash. Okay, this is my 25. This is my, this is going to be my capital A. Capital A in the sense what? Actual lines N. Right? So how it is drawn, I can say. The above distance of NA, okay, the above distance, that is this one. Okay, the above distance of NA, I can measure it and I can transfer it here from B. Okay, this is 20. This is going to be my capital A. Again, right, it will give me the capital A. Actual line N, one end. So similarly, for the other end, I can transfer the in front of distance of NB. I can transfer it here. Right. The above distance of NB, if I can transfer it here. Right. So what is this? This is 40. Okay. 45. 40. This is 40. 40, we can transfer it here. Okay, I'm getting B here. Similarly, this is 45. So this is 45. Actually, above distance of NB is 45. So I'm getting here. This is my NB. Okay, if I join this A and B, this is going to be my original line. Okay, so which is my true length? Actual original line length is true length is AB. Okay, AB I can straight away, I can measure it, I can give it. Okay, this is going to be my true length. Right, this is going to be my true length. This is the top view length, this is the front view length. Right, so how I can mark the horizontal trace and vertical trace, and it is, again it is simple. Okay, just I can extend this front view and I can extend the original line on the same. Right. So wherever it meets, that is going to be my what? It is going to be my vertical trace, VT. So if I extend the front view in this method, rotating line method, if I extend the front view, I will get the horizontal trace. Here, if I extend the front view and the original line, I will get the vertical trace. Similarly, if I can extend the top views on the same fashion, top view and the original line, see, so I have got the horizontal trace. Right. So this is how I can mark the horizontal trace 25. Once you have the final projection, using trapezoidal method, I can draw it as it is. I can get the final, I can get the true length, I can draw what? Vertical trace, horizontal trace. What else I have to find out? theta phi. So the theta, how I can know, which is theta, is nothing but the inclination of the original line to the reference line. Okay, original line to the reference line. So this is the inclination of the original line. If I draw a horizontal to this, okay, if I draw a horizontal, this inclination is nothing but my phi. Whatever I am getting above, going to get using trapezoidal method, that will be phi. So similarly here, this is the original line. Okay. So parallel to the view, there is nothing but parallel to the reference line. Okay, this angle is my theta. Just remember, this is going to be my theta. This is going to be my phi. Is it clear? So how I have obtained this? Okay, from the 3D only I can explain that. Right. It is called trapezoidal method. Okay. I can see this original line and the projection. Okay. Projection, its projection. So it will form a trapezoidal. You can see here. So I am considering the original line and the front view alone. Right. So you can see this. It is forming a trapezoidal. Right. What I can do? Just I can open this trapezoidal plane. Okay. Trapezoidal plane. I can make it align to the vertical plane. What will happen? So this is perpendicular to the vertical plane. This line. Okay. So if I open this trapezoidal plane and make it align to the vertical plane, it will be perpendicular to this. I can open it like this. So I can open this perpendicularly. I can open this. Okay. What is the distance? If I open, what is the distance? It is going to lie on the vertical plane. This is the distance. Right. What is this distance? It is the in front of distance. Okay. It is the in front of distance. I am going to use it. Okay. On the vertical plane. Right. That's what. So this in front of distance. This in front of distance. I am going to, that is 25. I am going to mark it here. Okay. This is my actual A. If I rotate this trapezoidal plane, make it align to the vertical plane, this is going to be A. Similarly, this one, B, it is nothing but 40 mm. So this I can, 40 mm, I can mark it. This is going to be again B. So this is nothing but my original line. Okay, AB. So what is this inclination? I told it is what? It is phi. Right. How it is phi? You can see here. This line, what it is comes from the trapezoidal plane. What I have hatched. Okay. This inclination. What is this inclination? To vertical plane. Okay. This inclination is nothing but my phi inclination to the vertical plane. I had this inclination. This is my phi. That's phi only. I have tilted, okay, I have made it align on the vertical plane. Okay, I am getting here. Okay, is it clear? So this phi only, this trapezoidal plane only I have opened and I have aligned on the vertical plane. So this is my phi. So I told if I join this final front view and the original line, this is going to the original line. It will meet on the vertical trace. Okay, if I extend the same thing, see here, it has to meet the vertical trace. Okay. Okay, it has to go and meet the vertical trace. I have to get it here. As I told earlier, so So I have to extend, to get the vertical trace, I have to extend the final front view at the original line. Okay, what I am having on the vertical plane. I have rotated this trapezoidal plane, okay, and I have matched it to the vertical plane. Okay, this is the matched one, that is AB and A', B'. If I extend this in the same fashion, okay, wherever it meets, it goes and meets, that is going to be my vertical trace. So already in the previous method where I had the vertical trace, at the same place I have got the vertical trace. Okay, that's what I was trying to attain, right? So the previous method we had the vertical trace, I have explained, okay, on the same place. Okay, in the trapezoidal procedure also will be attaining on the same vertical. You have to attain on the same place, right? Is it clear now? So on the same plane, if I take this trapezoidal plane, that is the original line AB and the top view, okay, then if I open it on the horizontal plane, what is this distance going to be? Above distance. This is going to be my above distance of NB. Okay, this I can make it rotate and I can align it on the horizontal plane. Whatever thing I will be getting here, that is going to be the perpendicular, and the in front of above distance I will be marking here. Okay, this is going to be my above distance. Okay, that using that I can get the original line again. Okay, so the same fashion, original line I will have, that is AB. So that will give you the again true length. Extending that original line and the top view where it meets, that is the location of my horizontal trace, right? So since I am using the trapezoidal plane, okay, so this method is the trapezoidal method, okay. So the original line and the projection will form a trapezoid, okay. So using that trapezoidal plane, I am trying to find out the true length and the true inclination. Okay, that method is called trapezoidal method, right? So clear. So either you can follow this rotating line method to find out the true length and true inclination, or the trapezoidal method to find out the true length and true inclination, and to mark the traces also, right? This is my phi. Okay, actual original line was this is phi, right? So the same phi angle I can measure it. Same theta I can measure it here. The theta is this. Come to this. This is going to be my theta. Okay, the overall angle. This is going to be my theta. This is going to be my phi. That's what I have measured here. Okay, you need not extend it, and you have to measure. You can draw a parallel line to the front view. So with the true length line, okay, true line, what is the inclination? That is phi. You can draw a parallel line to the top view. Okay, that inclination is going to be your theta. Right. Move on to the next problem. Take the problem. This we have to find it out. Take the problem. A line AB of length, this is nothing but my true length, is 70 mm, has its end A 15 mm above HP and 10 mm in front of BP. Right. Top view and front view length measures 60 mm, 40 mm. Front view length, 40 mm. Full stop. Draw the projections of the line and find the true inclinations of the line respect to horizontal plane HP and VP. Projections of the line and find the true inclinations of the line with respect to horizontal plane and vertical plane. So you have to find out theta, you have to find phi. So this is my X reference line, this is VP, HP. You can draw one projector. A dash A. Right. Then true length is given, top view length is given, front view length is given. Okay. Where you will use front view length, which is front view length. Okay. The first problem you know. Okay. Which is front view length? A dash B2 dash. Right. It is horizontally above the reference line. So what I can draw? I can draw a front view length that is 40 mm. 40 mm. I can draw the front view. This is my notation B2 dash. Right. Similarly, this is my front view length. Top view length. Similarly, that is nothing but A rotation. A11. That is 60. So I can mark the top view AB1. Right. This is my top view length. What I can do then, one more data I have is, I haven't used is the true length. How I can proceed to find the theta and phi? I can draw a projectile line for these two ends. Right. I can draw a projectile line vertically downwards. Okay. So to get the vertically downwards, I can draw a projectile line. Similarly, from end B1, I can draw a projectile line vertically. To get the true length and true inclination theta, okay, to use the true length, find the true inclination theta, which one I have to connect? A dash and I have to get the B1 dash. Okay, what is the true length? You have to use the true length as 70. Okay, I can use 70 mm. So I can use 70 mm. This is my A dash and this is my this B dash will be B1 dash. So what I will have here, I will have my locus here. So same way I can use a true length for the find out phi. What is this angle? This is going to be my theta. Right. So to find phi, what I can do it? I can, so same true length I can 70 what you have in your compass, okay, I can use that and I can get the location of B2. Right. 70 I can use it. So this is going to be my B2. B2 dash top view is B2. Right. Here I will have another locus. Right. So what will be this angle? This is phi. This what you have to find it out. So you are asked to draw the projection also. Then how I can draw the projection from this stage? Just I can tilt the front view length to the top locus and the top view length to the bottom locus. Joining that I will get the final front view and top view. So I have my two locus, top and bottom locus. Right. Just I can rotate it. Just I can rotate it. Rotate the front view length. I can get similarly the top view thing I can rotate it. Either I can rotate it or I can attain the final top view of end B. How I can attain? I can draw a projectile line wherever it intersects the bottom locus. There. So this is the one. If I rotate it, it has to match with this location. Right. So this is the location of B. This is the location of B dash. So just I can connect A and B dash. This is going to be my final projection. This is final front view, this is my final top view. Right. So what you have to do in this problem, so what are all the given data that you have to dimensionate? Okay, all this problem. What are the asked data that you have to dimensionate? What are the given data? This is AB is given in this problem concern. AB I have, where I have AB, true length. This is my true length. A dash, B1 dash is my true length 70 mm. That you have done dimension. This is my 70 mm. Right. So then what is A? NA? This one you have to dimension it. This is the arrow head outside. This is my 10. Then the top view length, front view length is given. This is my top view length. This you have to dimension it. How I can dimension it? If you have more gap here, you can dimension it, because the dimension line should have 10 mm gap from the entity which you are dimensioning. This is top view length. This 60. And this I have. You can extend it. What are the data task is theta and phi. You have to neatly dimension this theta and this phi. So you have to find it out, you have to measure it, and this theta and phi you have to write. This is my theta, this is my phi. So whatever you are getting, that you have to measure it and you have to write it. Right. Line AB of length 65 mm has its end A 20 mm above HP and 10 mm in front of BP. Full stop. Top view length of the line is 60 mm, which is 30° inclined to the reference line. Which is 30° inclined to the reference line. What it means? The top view length is 60 mm and that top view length, okay, that top view is 60. That in what angle is this? 30°. So what is the notation of this angle? Beta. Beta, right. Beta is 30°. Not phi. It is beta, it is an apparent inclination of the top view, right? Top view inclination, beta is 30°. So stop and find it true inclinations respecting horizontal and vertical plane. Respect to the horizontal and vertical plane. So find the theta, find phi. Just have the correction. Let's see here. Line. They had a problem. If the problem is correct, the line AB has its end B 60 mm above HP, has its end B. Has its end B. So one end B height is given. So end B is not beta. B is 60 mm above HP. Right. This top view length, correct it. 65 mm. Right, just correctly. Now, what you have to find out? Find the true length and true inclination. Add the true length also. Add the true length also. Try to find out true length and true inclinations. Right? Can I solve this? See here. Draw the reference line. Figuring plot the data first of all, x, y, this is BP, this is HP. So add in the problem, also mark the traces, So I can add horizontal trace, I have to get vertical trace. Right, I have the reference line vertical plane and horizontal plane. How to solve it? What are the data given? You try to mark the data. Right. First of all, the first one is data is 60 mm of end B. What is that? End B is 60 mm above HP in the sense. What is end B is 60 mm above HP in the sense what? That is nothing but the data given for the to draw the locus. Okay, the end B is above height. Find that end B is above height. That is 60 mm. So I can mark 60 mm. From 60 mm, I can measure. This is going to be 60 mm. This is C. So this is nothing but my locus of B dash. Right. The first data. What is the second one? It is 20 mm above HP and 10 mm instead of. That is nothing but NA. I can draw a projectile line. So it is 20 mm above HP. Above 3 times we will be marking above the reference line. It is A dash. And 10 mm in front of VP. 10 mm in front of VP. It is A. So there is nothing but 20 mm and 10 mm. This is 20 mm. This is 10 mm. Right. So then what is the data given? What is the data given? It is top view length 65 mm. A B1. Right. A B1, it is a parallel line, parallel to the horizontal line, parallel to the reference line. So A B1, I can measure it for 65. This is my A B1. So the top view length from the first assumption, I will use the true length and the true inclination. I will end up with that top view length. This is my 65. Right. This is my 65. I can dimension this. 65. Right. So then, what is another data? It is beta. Beta is 30 degree. Right. Beta is 30 degree. What I can do is beta is 30 degree, which is going to be beta top view length. Beta is nothing but top view angle. So this is my top view length. This is my top view length I have. So the top view inclination is 30 degree. What I can do it? So I can draw a 30 degree line. I can draw a 30 degree line. This angle is 30 degree. So what it means, it is beta. So what it means, on this 30 degree line, what you should have? You should have the top view. Okay, top view. In the sense, what is top view length you have? 65. That I can mark it on the 30 degree line. So I can mark that 65. Mark that 65. That is nothing but by rotating this, I can end up with this. This is my what? This is my what? It is going to be my final end B. So this A and B is nothing but my final top view. This is my final top view. Now you have got the final top view through this given 5 data. Right, using this 5 data, I have got the final top view. Then how I can get theta, phi and true length? What I can do it? What I can do it, just you can project this end B to the top locus. What I can get? B and B dash. I can project this, I can to the top end, top locus. So B and B will fall on the same projectile line. So this is going to be my B dash. So joining A dash and B dash, Joining A dash. So I have got my final projections, that is AB and A dash, B dash and AB. Then what is asked? Theta is asked, phi is asked. What I can do it? Either you can proceed with the true length asked. Either you can proceed with trapezoidal procedure. Trapezoidal method you can follow it, or you can use the rotating line method. So theta, phi and true length. How we can find out the rotating line method? It's your choice. You can either go by trapezoidal method or rotating line method. So how I can use the rotating line method? How I can find it out? Already I have B1. What I can do is I can project it to the top one locus. Okay. By joining that I will get the true length and true inclination of what? True inclination to HP. So this is my top view length. This top view length is obtained from the first assumption using the true length and the true inclination. This is going to be my B1 dash. Right. Joining this A dash and B1 dash. Joining this A dash and B1 dash. This is my what? This is going to be my true length. You have to measure it, and this angle is going to be my theta. So this is a true length. This is a theta. Now how I can find out phi? I have this front view. Front view I can rotate it. What I can do? The front view I can rotate it and make it parallel. I will get the front view length. Right. With that I can project it to the bottom locus. Do you have the bottom locus? At the B. At B I can draw a bottom locus parallel to the reference line. This is nothing but my locus of B. Right, by rotating this, this is nothing but my B2 dash. This I can project it here. This is going to be my B2. Joining this A and B2. Is again my, what is this? AB2. It's again my true length. True length. This angle what you are going to show it by measuring, it is going to be my phi. That's it. You have to measure it and you have to indicate the angle you should get is the answer for this theta. This theta I have 32 degree theta. So the answer for this theta is 32 degrees. Phi you have to get it as 25 degree. True length is 78 mm. So now you have to mark the horizontal trace and vertical trace. What is the procedure? I can extend the front view. Okay, on the same front view is nothing but the top one A dash B dash. I can extend it. I can mark it here. This is my small h. I can draw a vertical line that, okay, extend the top view on the same fashion. Okay, the top view I can extend it. Wherever it meets the vertical line, that is my horizontal trace. Right. So how I can mark the vertical trace? Extend the top view first. Where it meets the reference line, so already it is meeting the reference line here, so that is my small v. Right, there I can draw a vertical line. Then extend the front, already it is extended, that front where it meets the vertical line here, that is my vertical trace. Right, so you have to solve this problem. Okay, we will proceed another problem, take another problem. The line AB has its, the line AB of length 8 has its midpoint M, has its midpoint M. So has its midpoint, see here, midpoint M is 60 mm above HP and 50 mm in front of VP. 60 mm above HP and 50 mm in front of VP. Here it is not the end, it is given the midpoint of the line, right? So 50 mm in front of VP. Full stop. The line is 30 degree inclined to HP. The line is 30 degree inclined to HP. And 45 degree inclined to VP. And 45 degree inclined to VP. 45 degree inclined to VP. Draw the projections of the line. Draw the line. So it is inclined, the line is inclined. Theta is 30 degree. Phi is 45 degree. Just you are asked to draw the projection. So what is it? Similar to the very first both side inclined problem. Instead of an end, a midpoint projection you have to project it. Say, draw the reference line as usual. So this is my X, Y, this is VP, this is HP. So instead of one end, I have a midpoint projection. So you draw a projector in the middle, projector line, to project the point 60 mm above one, project the midpoint 60 mm above one, 50 mm in front of. So it is 60 mm above. Right, so 60 mm. So this is my what? M dash, small m dash. Right. So I am 50 mm in front of. This is my M, small m. So then what I have to do? As for the first step, I have to use the true length and the true inclination theta. What is the true length here? 80 mm. True inclination is theta 30 degree. So I can draw a 30 degree line here from midpoint projection. So I can draw a 30 degree line. So I can extend it on both directions. Why? It is the midpoint, but I have the midpoint projection only. I can extend it on both the directions. Right. So I have the projection of the midpoint. Okay, this is 30 degree. So I can use it. This is 30 degree. So what measurement I have to measure it? 40 mm. It is true length I have to measure it here. 40 mm. Okay, this side and 40 mm the other side of the midpoint projection, right? So 40 mm I have to measure it here. So I will have the true length. So similarly 40 mm the other side I will have the true length. Right. So this is going to be my what notation. So what is this note? This is 40. Other side is 40. The overall true length is 80. So what is this notation? What is this notation? I don't know the projections or the final projections of the both the ends here. The previous problem I had one end's projection. Here I have only midpoint projection. So I don't have the projections of both the ends. So I have given another notation here as per the first assumption. So this will be my A1 dash. This will be my B1 dash. Right. So I will have a locus here. So what is this locus? Locus of B dash. This is my locus of B dash. So what will be? I will have another locus here. This locus is locus of A dash. Right. So on this locus only I have to get my A dash. I have to get my A dash. Right. See here. this is 30 degree. I have to plan. What will be the top view length here? Where I have to mark the top view length? I have to project this A dash, B1 dash to where? Here at M. So I have to get the projection at the M, where I have the projection already. So I have to project this. So I have to project this. See here, this is going to be my top view length. Final top view length is, this is my A1, this is my B1. The whole thing is going to be my top view length. Whole thing is my top view length. So similarly, using the second assumption, I can use the true length and the true inclination 45. Okay, this 45. From where I have to measure? From M dash, I have to use the true length and the true inclination 45. So the true inclination 45. So how I can measure it? Either this way I have to draw it or this way. So similar to the previous problems, you use the same orientation. So 45 I have to measure it from 45 degree angle. 45 degree angle, I have to measure the true length here. The second assumption, I am going to draw this using the second assumption. This is my 40 mm here, I have to measure from M. This is going to be 1 inch. This is another 40. This is another M. See here, what will be this rotation? This angle is going to be 45. This is 45. So what will be these rotations? It will be at the second assumption, so I can give it as A1, A2, B2. Right. So I will have two locus here. Right. This is my locus of A. This is my locus of B. Right. So how I have to project this to get the front view length. Where I have to project and where I have to get the front view length. You should not get the front view length here. Where I have to get the front view length? At the midpoint. So I have to project get the projection at the midpoint. So this will be the projection. This is going to be my A2 dash, B2 dash. Right. Now what I can do is, I have got front view length, I have got top view length. Anybody, how I can get the final projection? After this, just you have to rotate the top view length to the top locus and bottom locus. You have to rotate the front view length to the... This is front view length, right? This is front view length, right? Just the front view length, I can rotate it to the top locus of the front view and bottom locus of the NDA locus of front view. Similarly, I can rotate the top view length to the NB's locus and top view length to the MA's locus, right? So just as a simple one, what I can do it, you see, just one thing you can rotate, any one. See here, this, the whole thing, how I have to rotate it, the whole thing A, front view length, whole thing I have to, about M, the whole thing about M, I have to rotate it like this. I have to rotate it like this. So instead of rotating the whole thing, what I can do is just using M dash as center, M dash, A2 dash as radius, just I can rotate this in a clockwise manner. So just by rotating this in a clockwise manner, so I can get Okay, just I am rotating this. So what is this rotation? It is going to be my locus of A dash. So it is going to be my A dash. Right. So from A dash and M, this is the projection of one half of the line. Front view of one half of the line. So on the same manner, if I extend it, it will meet the locus of B dash. So I can get another half of the front view projection. See here, on the same manner I am extending it. So it will meet the top locus. That is NB's locus. So that is going to be my B dash. Is it clear? Now how I can get the top view? I can draw the projectile from A dash and B dash to the bottom two locus, okay? Top view locus, right? NA is top view locus, NB is top view locus, right? So just I can project this. Similar way I can project this. Here. Here. So what is this? This is the locus of end A. So this is my A. This is going to be my B. So even though if you rotate this top view length using M, okay, midpoint projection, if you rotate it, you should get it here. Right? Should get it here. Similarly, this one, if I rotate it, the top one, you should get it here. So I can join this A and B. This is my M. Is it clear? This is going to be my final projection of the front view, final projections front view and top view. You can see lines, one end is on HP, another end is on B. So in this case, see, lines one end, suppose I have a straight line. Just see, this is going to be my reference line. So I have one end, another end, one end is A, is on HP, another end B is on B. Right? The line actual line will be like this. You see. Line like this. So in this orientation, you see what will be the front view of end A, where it will fall. Front view is going to obtain on vertical line will be. Front view of end A will fall on vertical line. But fall on where exactly? Reference line. So this one, the front view will fall on the reference line. So this is going to be my front view. This is my A dash. Right. Since this end is on HP, so the front view of that end will fall on the reference line. You see this end B, top view where I will obtain. The end B, top view where I will obtain. Again reference line. Top view notation is without dash. So the end B's top view will fall on. This is my top view. Top view notation is without dash, that is B, small b. Right. So this is A dash, this is B. So in this orientation, front view of one end will fall on the reference line, top view of the other end will fall on the reference line. Right. Now, what will be my front view? The line, the front view, overall front view. So similarly, you see, the front view of the other end line, end A's front view is falling on the reference line. End B's front view, where it will fall? On the same place, on the plane, on the same plane. So here I will have my end B's front view. Similarly, you see the same line. Top view of end B will fall on the reference line. Top view of end A will fall on the same location on the horizontal plane. So this is my A. Right. So joining these two ends, I will have my front view and top view. So this is going to be my front view. This is going to be my top view. So if I open this plane, so how will be this front view and top view? Again, so the reference line will be like this. X, Y. So open it. So one end projector, I can draw it. So here I will have my A dash. Right. Then on the same projector I will have A. So what will be this distance? A. End A is in front of distance. End A is in front of distance. I can mark my A. So I know the other end will be on the reference line. Right. Other end top is B is here. So what will be this distance? It is above distance of end B. Right. So I can mark B dash. This. So this is going to be my final front view. This is going to be my final top. What will be this length? It is a front view length. This is top view length. So these are all the inclinations. This is apparent inclination alpha. So this is going to be apparent inclination beta. That is top view inclination is apparent inclination beta. Right. Now we take a problem. So AB of length 70 mm. End A is on HP. End B is on VP. Right. Full stop. Draw the projections of the line. If the line is 30° inclined to HP and 40° inclined to VP. 40° inclined to VP. So how I am going to solve this problem? Similar to your both line inclined to both planes. Similar to the very first problem. I cannot solve it on a single step. I am going to get the final projection in 3 steps. You know how to get the final projections in 3 steps. Right. So as for this problem concern, I can solve it. I am going to solve this in 3 steps. This is going to be my xy. So I cannot solve it in a single step. It will be a little bit confused for you. That's why I am going for 3 steps. You see here first, as the first assumption what we will be doing, line is inclined only to HP and parallel to VP, right? Similar to that, I can have a point in the first step. That is my first A dash. I can mark it. I know A dash is on HP, right? Then the true inclination is 30, true length is 70. Using that 30 and 70, I can draw a line. So this is going to be my 70. Right. So this will give me my, what is this? B1. So there is an arbitrary location, B1 dash. Then I can project this. So this angle is 30°. And this is my true length. True length is nothing but 70. Right. So what is this? This will be my B1. So what will be this? A dash B1. It will be my top view length. And I will have a locus for this. Okay, where I have, this is nothing but the locus of my locus of B dash. Right, this you know. So I have got top view length, I have got the locus. Right. Then similar, the second step, how I will proceed? In the second step, I will know the line end B is, that is the top view of that line, end B is on VP. So the end B, the top view of the end B will be on the reference line. So I can mark that first of all. So the top view of end B will be on the reference line. So this is my end B. Right. And what is the true length and true inclinations to VP? That is 70 and 40. I can measure 70 and 40. I can measure 70 and 40. So this will be my A1. This is another top view location of end A. Okay, we don't know. So that is A1 I am giving. Sorry, already A1 I am giving. Right. So this I will project it to the location. What is this? This will be A1 dash. Right. From this second step, this is my 40 degree 5 inclination. What is A dash? A1 dash B. It is my front view length. So from this second assumption, I know this locus. I have got the locus of B. Locus of what? Of B. This is locus of B dash. Here it is locus of A. Locus of A. Right. So here it is locus of A. This is locus of B dash. So that is the difference we have. We are trying to find out the locus of this. We are trying to find out the locus of this. And we have got from these two steps, we have got the front view length and we have got the top view length. So now how I can draw the final projection? I know the front view length, I know the top view length, I have got two locus. I can mark conveniently, I can mark my end A dash. So I can measure the length, I can measure it. The front view length I can measure it. What I have got from the second step, so the front view length I can measure it. What I can do is from A dash I can cut it to the top locus. Right. So I can cut it to the top locus. This is my B dash. So this is nothing but my final front view. This is my front view length. So this inclination is my alpha. Alright. Now from this how I can get the final top view. Top view, you know, so it's definitely is going to be A dash, end A's projection will fall on a single projectile line. End B's projection will fall on another projectile line. We know directly I can mark it. We know end B's top view will be on the reference line. As per this orientation, end B's top view we know it should be on the reference line. That is my B. So what will be this? This is my A. So this I can join it. So you can cross check what should be this length. This is my top view length. This is going to be my beta. Right. So this top view length has to match with the top view length what you have got from the first step. Otherwise what you can do, you can mark B. Using the top view length I can cut it to the bottom locus. Right. That will coincide. Okay, well, it will fall on the same projectile line. Okay, this is how this kind of right away problem for lines one end is on HP and one end is on BP. You have to proceed it with 3 steps. Right. So you cannot draw it on the same place. If you draw it, you will get confused. Okay. We will try to draw it in 3 steps. Right. Is it clear? Similar to the first problem. Take the problem. The line AB has its end A on HP. And in front of BP, and in front of BP, full stop. End B on BP, end B on BP, and mm above HP, 40 mm above HP. So this sign indicates this is above. Right, 40 mm above HP. Full stop. The top view length and angle, the top view length and angle, measure top view length and angle, measure 70 mm. Beta, top view angle is beta, top view angle 70 mm and 45 degree, 70 mm and 45 degree respectively. The top view length and top view angle measure 70 mm and 45 degree respectively. This is beta. Right, full stop. Draw the projections of the line and find its true inclinations. Respect to horizontal and vertical plane. Full stop. Also mark the traces. So straight away you know this is line one end is on HP, another end is on BP. So my final projection is going to be like this. Right. So what is this distance? It is in front of distance of NDA. What is this distance? Above distance of end B. So what are the data given in this problem? NDA is given, B is given, that is two condition, that is NDA and B is on BP and HP. What is B? It is above distance. This distance is given. Above distance of N, B is given. Then what is given? Top view length is given. Top view length is this. And top view angle is given, that is this angle 45. Using this I can draw it. Right. So straight away get the projection. You draw the reference line. X, Y, BP, HP. Right. So one end I know that is on BP, that is my B. Right. And top view length I know, top view angle know as the previous one. So what is the top view angle? It is 45. For 45. Right. For 45. So this angle is going to be my 45. This is my beta. Beta is 45. So what is the top view length I have? It is 70 mm. So I can measure 70 mm. So I can measure 70 mm. This is going to be my final top view. What is this? A. This is my A. Right. Now, how I can get the final front view for this? Front view will be front view. So I know this ends projection will fall on the reference line. NDA's front view will fall on the reference line. From here I can draw the projector. Here I can mark my A dash. So how I can mark my B dash? B dash has to fall on the same projector on end B. So I can draw a projector line. So where I have to mark B dash? 40 it is given. 40 above it is given. From here 40 I can mark it. Right? Mark it. Right. I can measure 40. This is my B dash. Right. This is how I can finish my this distance given. So this is my 40. So 5 data 1, 2, 3, 4, 5. 5 data are given, so I have to mark it. Okay, this is top view length. So I can dimension this top view length. Actually, I have to dimension this top view length. Right. Now, you are asked to find out what? You are asked to find out true length. You are asked to find out theta. You are asked to find out phi. how I can find true length theta and phi, either rotating line method or trapezoidal. Which one will be easier here? If you are going for rotating line, you will get a little bit confused. I can go for my trapezoidal, it will be easier for me. So I can go for my trapezoidal procedure, I can find out true length and true inclination easily. So trapezoidal procedure you know. So I have to draw perpendicular to the front views and top views. So perpendicular, you see here, perpendicular. Right, similarly this is my perpendicular. Right. So what is the distance I have to mark it from on in front of this one? That is in front of distance. So this in front of distance, as per the trapezoidal procedure, I can mark the in front of distance. You measure this. This is the distance I am going to transfer it here. You measure this. Right. I can measure. I can mark. This is going to be my what? End A, capital A. Right. So what is the in front of distance of end B? 40. It is 0. It is 0. In front of distance of end B is 0. So the end B will fall on the same location. There is no in front of distance. B and A. Is it clear? So I can join AB. I can join AB. So what is this? This is the vertical line AB. What is this? This is nothing but my true length. I can measure this true length and can mark it. What is this? AB is nothing but my true length. What is this angle? This angle will be theta or phi? Phi. As per trapezoidal procedure, we will have phi here. Right. So this is my true length. So I have to measure that in this way. Then similarly, theta I have to measure it. Okay. Theta I will be getting here. So what is the above distance of end A that I have to mark it from here? What is the performance? What is the above distance of end A? 0. 0. So my A and A will be on the same location. Right. What is the above distance of end B? 40. So I can measure that 40. So right here I am having my end B. Right. So this A and so this is my above distance I am transferring here. This is my again my true length. The same true length I have to get. The angle theta will be this inclination. This angle is nothing but my theta. So you have to measure the true length. Both true lengths will be same. Theta will be different. Phi will be different. You have to measure it and you have to write it. Okay. Is it clear? Do you have any class?